So from phasor diagram, if you want to draw the phasor diagram, you have to study the equivalent circuit, right? In the last video we have done the equivalent circuit. So from the equivalent circuit you can draw the phasor diagram, right? So if you want to draw the phasor diagram of the transformer, then you back propagate. That means you start from the V2, load side V2, secondary side V2 to the primary side V1. So from V2 to V1 you back propagate and draw your phasor diagram. So I'll tell you some simple steps how to draw the phasor diagram. First of all, in step number 1, according to the given load condition, you have to draw the V2 and I2. V2 voltage V2 and current I2. Now here there are 4 possibilities. Either it will be lagging load, that means current I2 lags voltage V2, or it will be leading load, that means current I2 leads voltage V2, or it will be unity power factor load, that means V2 and I2 they are in same phase, right? So in fourth condition it may be no load condition, where I2 will be 0 almost, right? Load condition, no load condition, I2 0, right? So now here let me first see the phasor diagram. Let me first draw the phasor diagram at the lagging condition, right? So in lagging condition, draw the V2 and I2. V2 and I2 in lagging condition, I2 will be lagging by V2, right? So simply I am drawing V2. V2 is the reference phasor, so just draw it horizontally like this, right? Draw it horizontally like this. Okay, this is V1, right? So and I2, since you are saying it is lagging, so current I2 is lagging this voltage V2 by power factor angle phi 2, right? Or you can say cos phi is the power factor, right? So it is lagging, it's a lagging power factor angle, right? Phi is the power factor angle, load power factor, it is lagging, so I2 will lag the applied voltage, the load voltage V2. So this is V2, not V1, right? This is V2, right? So now I have drawn the V2 and I2 in the step number 1 as per the given load condition. For lagging power factor, I2 will lag V2, right? Now in second step, add drop I2R2 in V2, then draw J times of I2X2, right? So it's an inductive part, it will come with the J notation for AC values, right? You might have studied all these things in basic electrical technology. So here just add the drop I2R2 in V2 and then draw the J times of I2X2, right? So basically you see that I am back propagating, right? I am starting from V2, I have drawn this I2, and now I will add this drop I2R2 in this V2, right? Then I will add this J times of I2X2, right? Then I will get E2, right? So the same I'm going to do. So I2R2 means in phase with I2, it will be I2R2. So जो फेज आपका I2 का है उसी फेज में आपको I2R2 बनाना है. I2 is in this phase, so in the same phase you write I2R2. This is I2 and this is R2, right? Now J times of I2X2, that means J means 1 angle 90. J means 1 angle 90. J is the phasor notation. So rotate this phasor by 90 degree, right? With the same magnitude. So draw like this. So that means if you extend this line like this, then at 90 degree ahead in anti-clockwise direction, you have to draw this phasor j times of I2 x2. Alright, so this is j times of I2 x2, j times of I2 x2, right? So now you reach here, right? V2 plus I2 R2 plus j times of I2 x2. Now E2, right? If you take phasor sum of all these, you will get E2. So here, if you join like this, it will be the E2, it will be induced EMF E2, right? So let us say in the primary there are some less number of turns. So if I say N1 is less than N2, in that case E1 will be less than E2. So E1 will come somewhere around here, right? Because you are assuming that E1 is less than E2, because you are saying that N1 is less than N2, right? It can be more also, but for simplicity let me assume N1 is less than N2, so E1 is less than E2. Alright, now here, so this is basically, you see this, if you want to write the equation, then you can simply write E2 is equal to V2 plus I2 R2 plus j times of x2, right? I2 plus j times of x2, right? And remember, all these are phasor values, phasor notation. So let me represent the phasor notation. So if you even if you apply KVL, Kirchhoff's voltage law, you can get the same, right? E2 is equal to V2 plus I2 R2 plus j times of x2. So this is the corresponding phasor for this phasor equation, right? Now you see this E1 is less than E2 as per our assumption, N1 is less than N2, so E1 is less than E2, right? So now you can draw the flux and EMF. They both are in phase quadrature. Flux and EMF, they are in phase quadrature. That means the phase difference between flux and induced EMF is 90 degree. Since induced EMF comes from phasor, induced EMF comes from the flux, right? d phi by dt will give you the induced EMF. So that means flux will lead from the induced EMF, right, by 90 degree, like this. Okay, so this is the flux, right? This is the flux. Phase difference between flux and induced EMF is 90 degree, because flux and EMF both are in phase quadrature always. So this is the mutual flux phi m. All right, okay. So now if you take I2 in the another direction, that means it will be, you can draw I2 like this, isn't it? You can draw I2 like this. If you draw I2 like this, it will be I2 dash. That means it is referred value, this phasor same length but in another side, right? So you can see this is I2 dash, this is I2 dash, that is the referred value. I told you the meaning of referred values. So if this is I2, this is I2 dash, this is I2 dash, right? And I also told you that exciting current is almost in phase with the mutual flux, because it is produced by this mutual flux. So almost it is in phase with mutual flux. So you can draw this I2 like this, almost in phase with mutual flux like this, right? So this is basically exciting current or no load magnetizing current. Now you see this phasor sum of IE and I1, IE and I2 dash is basically I1. Phasor sum of IE and I2 dash is basically I1 only, right? See this, even if you apply Kirchhoff's current law at this node, you will know that phasor sum of I2 and IE is I1, right? All these are phasor values, needless to say, because we are dealing with AC, alternating currents, right? So IE plus I2 dash, phasor of these two is basically I1. So here you just take phasor sum of IE and I2 dash to get I1, right? Okay, so here this is the phasor sum of IE and I2 dash, that will give me this current I1, right? This is basically my primary current I1. Okay, right. Now in the next step, you extend this phasor backside, right? You have to extend this phasor E1 backside. You have to extend this phasor, right? So when you extend this phasor backside, you will draw like this, right? So just have a look at it. This is basically, you have to take the same length of the phasor, right? So this E1, when you back propagate, it will be E2 dash, right? E2 dash is a E1 dash. This is I'm taking the same phasor backside, so this is E1 dash, right? So here this is E1 dash, right? So since I'm taking back propagating it, you take a negative sign representing the Lenz law, so minus E1. So this is basically V1 dash. V1 dash is equal to minus E1, right? So if you have a look at it, this is V1 dash, it is basically minus of E1, right? V1 dash is equal to minus of E1. This is V1 dash is equal to minus E1. So V1 dash is equal to minus E1. Sorry, this is not E1 dash, this is E1, minus E1. V1 dash is equal to minus E1. I am taking same phasor and backside, so E1 minus E1, that is equal to V1 dash. Now you simply add this I1 R1 drop. So in phase of I1 there will be I1 and R1, right? So in phase of I1 this will be I1 and R1 drop. Let me write it below for ease of drawing, right? So in phase with I1, draw I1 and R1. So I'm going to draw this I1 and R1. Okay, I'm going to draw I1 and R1. This is I1, this phase and this phase, both are same because it is the resistive drop. So I1 and R1 both will be in same phase, right? So this I1 phase and I1 R1 phase both are same, right? Now add this Ji1 x1, add this Ji1 and x1, Ji1 and x1, right? So add this Ji1 and x1. So this is basically J times of I1 and x1. So basically I am taking the combined equivalent circuit, right? I am taking the combined equivalent circuit to draw the phasor diagram All right. So this is the circuit you are having, right? So I1 R1 plus J I1 X1. So you add this, it is J I1 times of X1, right? J I1 times of X1. All right. And when you take phasor sum of minus E1 plus I1 R1 plus I1 X1, you will get this V1, voltage V1, right? You will get this voltage V1. This is a voltage V1. So basically, even if you apply KVL, you will get V1 is equal to, you see this, this is basically V1 is equal to V1 dash, or that is equal to minus E1 plus I1 R1 plus J times of X1, right? These are all phasor values, right? So take a phasor notation. So that's how you draw this phasor diagram at lagging power factor, right? So this is a phasor diagram of the transformer at the lagging power factor. Similarly, you can draw the phasor diagram at the leading power factor. Yes, leading power factor also you can draw the phasor diagram. Okay, so start by the same method. If the power factor is leading, in that case I2 will lead the voltage V2, right? First of all, draw V2, that is a reference phasor, okay? And then draw I2, leading current I2 you draw. This is the leading current I2, this is the leading current I2. This is the leading current, because power factor is leading, power factor angle is phi, right? So see this is the leading power factor, I2 and V2. I2 is leading voltage V2 at leading power factor. So in step number 1 we have drawn I2, that is leading V2 at leading power factor angle is phi, right? Now in the second step, draw I2 R2, then draw GI2 X2, then get your E2, right? So that means you have to, in phase with this I2, draw I2 R2, right? Because it's a resistive voltage drop, so it will be in phase with I2, so I2 R2, right? Remember, these are referred values, right? These are all referred values. So I2 R2, right? Okay, so here V2 plus I2 R2 dash. Now GI2 X2 will be 90 degree ahead of this phasor. J means 1 angle 90. So you at 90 degree you draw J times of I2 into X2 dash, right? Okay, right? I2 X2. Okay, so here these are all phasor values, right? So here just V2 plus I2 R2 plus JX2 X2, you take phasor sum of all these take phasor sum of all these to get induced EMF E2 like this, right? Let us say E1 is less than E2, so this is E1, right? Flux and EMF both are in phase quadrature like this. This is phi m. So phase angle difference between phi m and E induced EMF E1 and E2, this is 90 degree. That is the meaning of phase quadrature. Quadrature means 90 degree phase displacement, right? So this is 90 degree phase between E induced EMF E1 E2 and phi m, right? I2 take back side, you will get I2 dash like this. This is I2 dash, right? So I2 dash is basically referred value, right? I2 dash is this, and IE, I told you it is almost in phase with phi m because it is produced by phi m, exciting current IE, right? Now take phasor sum of these two. You take phasor sum of these two. So this is I1, right? Phasor sum of I2 dash, phasor sum of I2 dash and IE is basically I1, right? Okay. Now back propagate this E1. When you back propagate this E1, you can draw like this. Right, this is basically E1. This phasor I am propagating back side like this, right? So this is basically minus E1. Minus E1, I told you it is nothing but V1 dash, right? Alright, minus E1 is nothing but V1 dash. So V1 dash is equal to minus E1. Now add I1 R1, right? Add I1 R1, resistive drop. So basically I am back propagating from V2 to V1, right? So here this is voltage V2. So here to get I1 R1 you have to draw in the same phase. This is V1, this is V1 is equal to I1, add this I1 R1. I1 R1 is in phase with I1, right? Now at 90 degree of this you add this JI1 X1, JI1 into X1, right? When you take phasor sum of these all, you will get this is V1. This is basically V1 dash, right? This is V1 dash and this is V1. So that's how you can draw the phasor at leading power factor where I2 is leading V2, right? Similarly, if you want to draw the phasor diagram at unity power factor, you can also draw. In that case, I2 will be in phase with V2. That's it, and all the remaining steps would be same as earlier, right? So you can also draw the phasor diagram at leading power factor. Very easily you can draw. All right. So if the phasor, if you want to draw at resistive load at unity power factor, then join I2 R2 in phase with V2. That means phase angle between I2 and V2 is 0, cos phi is 1, unity power factor. So draw V2, then in the same phase draw I2 R2 phasor ahead of V2, and then 90 degree with that you add J times of I2 X2. Take phasor sum of all these, get U2. Likewise, repeat all the process and you will get phasor for purely resistive load. So thank you very much. Thanks for watching. So like that you can draw the phasor diagrams.